Good evening, everyone. We're just going to wait a few, just maybe 30 more seconds while we get everyone into the Zoom room, and we will start our show. Okay, well, good evening. My name is Mindy O'Neill. I'm the Executive Director of the Cold Climate Housing Research Center, and we are super excited to invite you tonight to the SolarPV for Homeowners class. This is our last class of our Fall Energy series, and so we are really glad that you're here. If you'd like more information about Cold Climate Housing Research Center, please visit us at cchrc.org. I'd like to take a moment to thank our sponsors, GVEA, Alaska Housing Finance Corporation, Southeast Conference, and Solarize Fairbanks. Because of the generous support from our sponsors, all our classes are provided free of charge, and when applicable, we offer CEU credits. Special thanks to the teams who helped put this series together. Information Insights. Tonight we have Laura manning the room and background logistics, NREL, and Alaska Heat Smart. So just a few housekeeping items. For questions tonight, we do have a lot of great information. So we'll have a midpoint break where questions can be answered. And then there will be a time at the end of the session for more questions. We really want to value your time tonight and end on time. So if we do not get to your question, we will provide them to the speaker to respond individually. For Zoom, please keep yourself on mute, and we would love for you to participate in the polls. That really helps us gear these classes to what you, the audience, would like to see and gives us some more information about who you are and what you're looking for. You're welcome to leave your videos on or turn them off. If there are any bandwidth issues, which we don't expect, we'll request all of the videos to turn off. As I introduce our speaker this evening, please participate in the entry poll. Launch now. Tonight, we have Chris Pike from ACEP presenting. He began working with ACEP in 2012 and has been involved in projects ranging from studying the performance of solar thermal systems in the Arctic, geothermal exploration in Western Alaska, and working as part of the data collection and analyst team. Recently, he has been working as part of the Solar Technology Program team to improve our understanding of the performance of solar photovoltaics in the state and learn more about ways to reduce the cost of this energy. Take it away, Chris.
Perfect, thank you. And I always try to get photovoltaics into my intro as much as possible because it's fun to watch people trip over the word that we like to say all the time, right? Thanks for the intro, and thanks everybody for taking some time out of your evening to join us. Last I saw, the Phillies were up 4-0. So hopefully, I'm sure if there's some big baseball fans, you're probably split screening this, but we're going to take some time tonight to talk about solar, specifically for residential and small commercial applications. It looks like, I'm kind of looking at the poll here, it looks like we've got people from up and down the rail belt, primarily from Fairbanks, but we do have some representation from Anchorage, the Valley, and Kenai as well. So thanks a lot. Thanks a lot, everybody, for joining us. So again, my name is Chris Pike from the Alaska Center for Energy and Power. Kind kind of all these pictures here on this intro slide will be discussed later on and throughout the presentation in one form or another. And my email is down there. So again, if you want more information about anything that I talk about, or if you have additional questions, feel free to email me. Quick introduction of the Alaska Center for Energy and Power. If you're not aware of us, we are an applied research institute at the University of Alaska Fairbanks. Our mission is to foster the development of practical, innovative, and cost-effective solutions for Alaska and beyond, primarily in the North and Arctic and cold weather regions. While we are based at the University of Alaska Fairbanks, we do have offices of people in various areas of the state. I actually am located in Anchorage. I used to live in Fairbanks, and now I'm here in Anchorage. We also have a small office in Juneau. So we do have representation around the state. ASAP began in 2008. So we've been around for almost 15 years now, which is hard to believe. Our core programs, again, just to give a broader picture of what ASAP does, we have an active hydrokinetic research center and program. There's a hydrokinetic test bed located in the Tanana River, right next to the community of Nanana. We have a power systems integration lab, which is located right there on the Fairbanks campus. It essentially is a microgrid that can mimic the operation of a small Alaskan village that is primarily uses diesel generation to generate power. And then they can mimic the introduction of wind and solar and other types of variable renewable resources. We have a data collection analysis program where we focus on how to collect data from all these systems that we monitor. And then, of course, we have the solar technologies program, which I'm a part of. And as was mentioned during the introduction, we really try to focus on how to best utilize solar in the north and in the cold regions. We're also involved in a ton of other activities, everything ranging from renewables, projects ranging from renewables on the rail belt, some geothermal projects, and a whole bunch of other stuff. So I want to start tonight with some simple definitions, because I've oftentimes given these talks and realized that I throw words out like kilowatt and kilowatt hour and energy and power kind of interchangeably. And these are words that I tend to see on a daily basis, but for a lot of people, the only time they see them is when they open their electric bill every month. And even then, with auto pay, a lot of people don't even get an electric bill nowadays. So I just want to kind of quickly go through the difference between energy and power. So if I say words like watt and kilowatt, those are power, and you can think of power as instantaneous. So, you know, if I look and I'm using 17 kilowatts of power, just made that number up, that's an instantaneous amount. I'm not going to pay for 17 kilowatts, because what I pay for is energy, which is power as it over time, basically. And so what you pay for on your electric bill is 17 kilowatt hours. And so usually this becomes important because we talk about the amount of energy that you can expect a solar PV system or any other type of renewable resource to generate. And so we're talking about energy because it's happening over a period of time, but we might talk about the installed capacity of a solar array. So in that situation, I would be talking about a 5 kilowatt array. So that, and that's important because usually when we talk about solar arrays, we talk about the price per watt, so in terms of pricing those systems. So just a quick intro there. You'll hear these terms throughout, but I think it's important to start with that. And one thing I always talk about at the beginning of every talk about solar is I talk about energy efficiency, because I think it's neglectful to talk about generating your own electricity if you don't talk about ways that you can save electricity. And so one of the simplest ways is just to make sure that you're using all LEDs in your house. I've been given this presentation many times over the years. This used to be a big thing, although I have to say now it's hard to buy anything except an LED when you go to Lowe's or Home Depot or anywhere else. So probably someday I'll just get rid of this slide, but I do think it's important because even when we're talking about energy efficiency stuff besides LEDs, whether it's energy efficient fans or appliances or those kind of things, those are oftentimes going to cost a lot less than a solar array, and they're going to have a lot quicker payback. So while I am an advocate of solar, I think it's important to make sure you look at your energy usage from a holistic point of view and look at ways that you can save energy as well as ways that you can generate your own energy. Some things I'll talk about tonight. I will talk about the different components of a solar system, specifically rooftop solar, although I will talk about ground-mounted solar a little bit. I'll talk about solar resource data and how you can model yourself to approximate the amount of energy you can expect a solar array on your roof to generate. We'll talk about some economics and go over solar payback and some of the things that you can keep in mind when you size your solar system. And then finally, I'll try to put a lot of links in the final slide, which you can use for further investigation. I think it's important to remember that a presentation like this isn't going to answer all your questions, although I will do my best. And everybody kind of comes at this from a different perspective. Some folks will be interested in actually installing their own system, and that's great. And some folks are just looking to hire someone to do it for them and want to know what questions to ask. So hopefully we'll give you the tools to do all that stuff. We'll start with the solar resource data. This is a map of the United States, and then we have Alaska down near Mexico where they always throw us. And then over on the right, you can see a map of Germany. And in this particular map, bright colors mean you have a great solar resource. Blue means you have let's not call it poor, let's call it a medium solar resource. And purple means you have a less than desirable solar resource. And so I always show this map because a lot of times you hear the word solar in Alaska in the same sentences, and it just doesn't make sense. But it's important to remember that a lot of parts of Alaska have a similar solar resource to parts of Germany. And at one point, Germany had the most installed capacity of solar photovoltaics as anyone else in the world. They really were the country that kind of led the solar revolution. A lot of the best solar research still comes out of Germany. So I think it's important to remember that we obviously don't have the same solar resource as places like Arizona and New Mexico and Southern California. But that doesn't mean that solar isn't viable here. It's going to have some different constraints, and it may not have the payback time that you see in other places, but it is still something to keep in mind as an option. Some quick nuts and bolts on how a solar panel works. And right now this particular slide is really just focused on how the wafers, the cells of a solar panel work. And this gets pretty into the weeds, so I'm not going to spend a lot of time here, but the way that you can think about it is you have a photon of light or a little packet of energy that comes from the sun. It will knock an electron off of an atom. That electron flows through a junction and it completes a circuit and forms electricity. And you could get a lot more detailed if you wanted, but that's kind of all you really need to know. And then these solar cells are wired together to form a module, and modules that are then wired together to form a solar array. And you can get solar arrays that are as little as one module, and you can get solar arrays that are hundreds of thousands of modules. As an example of what we see here in Alaska, there's an 8.5 megawatt solar array that's currently being installed in Houston, Alaska, just north of Wasilla. That particular array is using over 14,000 modules, and that's being constructed. right now and into next year. Some of the different components of a grid-tied solar system, and I'm going to talk about these, and then I'll go into the individual components and talk about the components themselves. So at the top there, you have your actual array, and these are basically a bunch of photovoltaic or solar panels wired together, typically in series, although it does depend a little bit. Solar panels produce DC electricity or direct current. What we use in our homes is actually alternating current. And we can definitely make the comment that a lot of our computers use direct current, but for now, we're going to assume that everything uses alternating current, such as our lights and all that kind of stuff. Excuse me. And so that DC current comes off of the solar array. It goes into something called an inverter. The inverter is what changes the DC current to the AC current. And then from there, it goes through a disconnect, and then it goes usually into the main breaker panel of a home, where it's distributed throughout the loads in your house, and any extra energy or any extra power that you're not consuming will flow out your meter and out to the grid and to wherever it's needed. So in this case, it's probably going to be your neighbor's house or something like that. So we have the panels. Under the panels is the racking that holds the panels to your roof. There's the cables that connect all this together. The inverter that I mentioned, this disconnect, this meter is an important part. In most systems, these are called bidirectional meters, and so they can measure the amount of energy that flows from the grid to your home, as well as the amount of energy that flows from your home back onto the grid. And then in most modern solar systems, there is also a monitoring system that you can use. Basically, you can access it, on your phone, and you can see how much solar energy you're producing at any given time from anywhere. These are typically what modules on a roof will look like. I will say that in Fairbanks, because you guys are a little bit further north, most of the installations are canted up from the actual roof angle. So you might see, as you're driving around town, you'll see the solar panels installed at a steeper angle than the actual roof. This particular roof, I believe, is a 312 pitch. And so these modules are at, I think it's 18 degrees, but I'd have to double check that, parallel with the roof. And I'll talk about what tilt angle to install the modules at a little bit later. Although suffice it to say, it kind of depends. And it might depend on where you're located, how much wind loading you have, what your goals are for snow shedding, how much snow cover you are willing to endure, how much it would cost to have it installed at an angle steeper than your roof, things like that. But this particular type of installation is very, very common in South Central Alaska, where you have modules that are just installed parallel to the roof. The first question everybody asks is about snow coverage of these modules. I don't think I've ever given a presentation and not been asked about snow on the modules. And so this actually is on my roof. And these modules typically get covered about now, late October, around the first snow where it stays cold. And they will stay covered depending upon the year. If I didn't remove any snow, they would probably stay covered through the end of March. Some years I might get up there and I might just take a broom and push the snow off the modules sometime in March. When I go over solar resource a little bit later, I will say that there's not a lot of energy that you're going to get from solar during November, December, January, and February. There is some, but there's not a lot. And so, if you actually look at what you're going to get from removing snow off your modules, it's probably not going to be be worth very much money. Other types of PV modules. So this type that I just showed on the roof, these are monofacial modules. So you can see they're not transparent. You cannot see through those. And now what we're seeing more and more is we're seeing bifacial modules. The Houston array that I mentioned a little while ago is being installed with bifacial modules. So bifacial modules essentially have glass on the front and they also have glass on the back. And so that allows the modules to absorb light from both directions, which is a big deal in places like Alaska where you have snow cover over the ground for long periods of the year, especially like in March, April, and even into early May, depending upon where you're located. We have a test site located in Fairbanks that was on that intro slide. The bifacial modules show a gain of 21% over the monofacial modules at that particular site. We're also monitoring the bifacial gain from a large array in Kotzebue and seeing very high bifacial gains, particularly because Kotzebue has snow cover that goes oftentimes well into May. It's pretty amazing the production that you see from that array during the springtime. But you can see in this image here that when you have bifacial modules and bright snow, that you kind of get sun coming from every which way. And I always joke that there's a reason that the first sunglasses were really developed by indigenous people in the north. And when you go out onto the tundra in an April or a May day and it's bright snow, it's really, really hard to function without some kind of eye protection. These are so if you are interested in doing some more education and you're actually looking at the tags on the back of some modules, this is what you're going to see. And so if it's a monofacial module, you can look at the tag on the right and where it says max power, that's how much power you can expect that module to produce on a really bright, sunny, cool day. And these modules are tested in very controlled conditions, and they are tested at 25 degrees C. And if you think about 25 degrees C, that's actually not that hot. And so, especially in the deserts and that kind of those kind of situations, they're actually rarely going to be producing that 270 watts. In Alaska, we will see the temperatures that they're rated at, but they're also rated at 1,000 watts per meter square, which is a measure of the irradiance. We don't get that too often, but this is these tags on the back of the modules are ways that you can go in and compare one module to another. Here on the left side, this is the tag that you're going to see either on the spec sheet or the back of a bifacial module. Actually, it wouldn't be a back because it's a bifacial module. Usually they put it right on the frame because you don't want to cover up the back of the module. And so what you can see is there's actually two different modules here. One is a 405 watt module. The other is a 400 watt module. And then they give two more columns here. The one that says Bi-Fi 100 means that this is the amount of power that you can expect that module to produce if it's getting 100 watts per meter square from the back of the panel. So maybe if it were, maybe not like a bright snowy ground cover, but something even like grass or something like that. And then the 455 is what you can expect that to produce if it's getting 200 watts per meter from the back of the module. So you could think of that as something like snow cover or something like that. And you can actually expect even higher outputs on snowy days. So that's kind of, I don't want to get too into the weeds here, but if you're out looking at solar panels, you will probably see these tags. The other thing you can pay attention here is this bifaciality coefficient. Bifacial solar panels are not as efficient on the backside as they are on the front. So that means if you have the same amount of irradiance hitting the front of the panel as hitting the back of the panel is only going to produce about 70% as much as the front of the panel. And different types of module designs will have different bifaciality coefficients. So it's just things to keep in mind. The other thing you'll see if you're out looking for panels, you know, at either RES or ABS or any other shops there in Fairbanks or here in Anchorage, or you're doing some research online, is these half-cut panels. And so essentially what they've done is they've taken a wafer of silicon and they've cut it in half, and then they wire it so that you essentially have the top of the panel is wired in series and the bottom of the panel is wired in series, and then they're wired in parallel together. And what that does is on a traditional solar panel, if you have some shading on a particular part of the solar panel, you're going to lose all these red dots of production. You can think of those as like units of production on a standard panel. But on these half-cut panels, because of the way they're wired, rather than a third of the panel, you're only going to lose a sixth of the panel's worth of production. So these type of panels are designed to be more efficient in situations where you have shading or partial snow cover or things like that. Moving on to the inverters, that which was kind of the next item in the order of that drawing that I showed earlier, that converts the DC energy to DC power to AC power. There's two main designs that you'll see in residential installations. One is a string inverter, and a string inverter, basically all the modules are wired together, and then it goes through the inverter. And that inverter is typically on the wall of a home or something like that. You also have what are called microinverters, and microinverters will turn the DC energy to AC directly behind the panels. And so those, you can see this particular diagram here shows the inverter located on back of the panels attached to the racking. And then so rather than DC electricity flowing through those wires between the modules and your home, you basically have AC electricity flowing directly from the inverter through the wires to the disconnect and then into the home. Most of the residential installers around the state are using microinverters nowadays. Very few people are using string inverters. They're just a little bit easier to work with, and you can monitor individual panels and that kind of stuff. Some people still like the string inverters. Goes both ways. There are some code issues with string inverters, but those can be addressed, and I don't want to get too into the weeds there, but just things to be aware of. So these are just some really quick diagrams about the two types of inverters. If you're working with a string or a central inverter, basically all the modules are wired together, and then they are going to be wired through that inverter, and then the inverter is wired into the house. For the microinverters, like I said, the DC electricity is turned to AC electricity on the roof of the house, and then all the inverters are wired together, and then the electricity flows to the house from there. And then there's another kind which is kind of like a combination of the two, and basically it's they're called power optimizers. And when the DC power flows out of the solar panels, it goes through these optimizers, and then it stays DC, but it then goes through the inverter, which is located usually on the wall of a house or in the garage or something like that. The optimizers are kind of a combination of the two because they allow you to monitor the performance of each individual module or solar panel, and they also make it so that if one solar panel is shaded, it's not going to reduce the output of the rest of the solar panels, which can happen in a string inverter. This power optimizer design, you usually don't see it unless you're working with very large systems. But you may hear, if you're talking to a solar installer, you may hear them talking about like a solar edge system with power optimizers or something like that. So you can know what they're talking about. So I said at the beginning of this that most of what I would talk about was rooftop, but I would touch on some ground mounted stuff. So different types of ground mounted installations. There's a couple different kinds here. These particular kinds are actually called ballasted systems, in that they don't actually have penetrations that go into the soil. They're held down with ballast or weight that is attached to the actual racking. And so you can see on the right side, there's big concrete blocks that are attached to that racking. And on the left side here, they actually used, behind the dog here, they actually used big bags of sand that are attached to the racking, so that they didn't actually have to drive the piling into the ground there. It's just, it makes it slightly less expensive. These are what's called pole mounted. And so here you have individual poles that are driven into the ground. A lot of times they'll put concrete in the bottom of the hole to hold everything upright. And then you have racking on that is actually attached to the pole that holds the solar panels. There is a limit about how big you can get these. Obviously, if you're supporting it with just a single pole, a lot of times it's either 4 or 6 inch piling that you would use. These tend to be really common with tracking arrays. So arrays that will track the sun either on a single axis or on a dual axis. I think this particular array here is located in Eagle, Alaska. I don't think it's a tracking array, actually. I just think it's just a regular pole mounted array. You don't see a huge number of these. They were more common about 10 years ago, but there are still some around. And for rooftop arrays, there's a couple different varieties. You heard me say at the beginning that most of the arrays in Fairbanks, the rooftop arrays are canted up, so they're at a steeper tilt angle than the roof. You see an example of that here in the bottom right. This is actually an array, a rooftop array in a village that is designed in such a way that it can produce power during the summer for a large part of the day. That's why they have part of the array facing south, and then part of the array is also facing east there. This is what the racking here on the top left, this is what the racking usually looks like under the actual solar panels. And so the panels will attach to this racking right on the top of the roof. The racking is bolted into the trusses in the roof with bolts. I think they typically use about 4-inch lag bolts, depending on what the code is and the wind loading is in that particular area. There's different styles of attaching this racking to the roof, depending upon what kind of roof you have. So you can see here in the top right, that's for a composite roof. On the top left there, on the top right, this is a metal roof. And so there's a slightly different kind of flashing material, and I'll show that in a later slide. And then of course, this is actually a standing seam roof there on the bottom left. And so that particular kind of racking actually just attaches to the seam of the roof. It doesn't actually penetrate the roof. Some authorities, some communities will allow that, some will not. It just depends on the building inspector, but that's a really common thing to do as well. And there's certain kinds of clamps that will clamp onto those standing seam roofs. As I mentioned, there's different types of flashing that's used. Another really common question that we get is about roof leaks, because in a lot of these designs, you are penetrating the roof. So you're putting a bolt through your roof, and that always makes everybody, including myself, nervous. Can't say it's never going to happen, but I think the industry as a whole realizes that it's really bad press when people have roof leaks. And so the installers will definitely try, installers are very incentivized to find systems and use quality systems that are not going to result in roof leaks. So typically what happens is you, on a lot of the composite roofs, you might have a piece of flashing that actually slides under the row of shingles above it. And so it basically becomes part of the roof. And then you can't really see it here, but there's some additional flashing that actually goes around this bolt here. And then usually what will happen is they'll also put some kind of like a roofing adhesive or something around that bolt to just provide an additional level of sealant there. This kind of flashing on the right is becoming more and more common, and people are successfully using that. Basically, it's a type of rubber that really bonds well to the roof, and so water can't get in there. And then for metal roofs and that type of thing, sometimes you'll see this kind of flashing as you see here in the bottom. I bet there's hundreds of kinds of flashings if you really want to get into it. So these are just 3 examples. And if you Google for 5 minutes online, you'll find lots and lots of examples of different stuff. But just as an example, these are kind of some of the things that are out there. I mentioned tracking earlier. These systems are actually located over at the Cold Climate Housing Research Center there in Fairbanks. These particular systems are 2-axis tracking, so they track up and down as well as side to side. They're designed so that they are always pointing at the sun. These were really popular 10 or 15 years ago, and the thing that really changed is the cost of the solar panels. So back then, solar panels were much more expensive, whereas nowadays solar panels might be 50 cents a watt. Back then, they might have been $5 a watt. So an order of magnitude more expensive, and they really wanted to be able to generate the most amount of energy for the smallest number of panels, and you can do that with tracking systems. Tracking systems tend to require more maintenance because there are moving parts. Anytime you get moving parts in the cold, they stop working at some point. So they do generate more energy on an annual basis. And for some people, they're willing to go out there and fiddle with things. But for the majority of people, a fixed tilt array probably makes more sense, just because that's going to be a lot less long-term maintenance. The building inspectors and the utilities all will require some kind of a utility disconnect or a solar disconnect. This is an example of one located in Fairbanks. They will look a little bit different depending upon what utility you are located in. And the idea is that if there is some work that needs to be done by a lineman near your house, they want to be absolutely sure that there's not any power being generated by your PV system that's flowing back into the lines. These disconnects are a little bit redundant because all of the inverters are constructed in such a way that anytime they do not sense a voltage coming from the grid, they automatically shut down and don't allow power to be generated. But obviously, if you're a lineman or a worker or something like that, you want to be doubly sure that that you're safe. And so these disconnects are required whenever you install a grid tied PV system. So we've covered the modules, we've covered the racking, we've covered the inverters, we've covered the disconnect, and so the kind of the final piece in that puzzle, as you're getting that solar powered off your roof into your house, is how do you wire that into your house? And again, this is for grid tied solar, not talking about batteries quite yet. So there's a couple of different ways you can do that, and it's very, very rare for a homeowner to do this themselves. If it's just for their home, technically it is allowed, but definitely recommend getting an electrician involved. You can either do that in your breaker box, where where your distribution box, where the the different circuits are fed from in your home, and you can also do a line side tap, which is basically between the meter and the breaker box. And so, this is getting pretty detailed as far as what an electrician would normally do, but it does get asked sometimes. So it is good to kind of just have this in the back of your mind, especially if you want to ask an installer or someone that's going to install your system how they intend to interconnect it with your house, so you have a little bit of that background knowledge. I did mention that most of these systems, pretty much all the systems being installed nowadays, have monitoring of one type or another. This particular monitoring comes off this particular monitoring system is off of a SolarEdge system with optimizers that I mentioned earlier, so you can see the production from each of the modules. And so it's telling you that up until this point in the day, each module had produced about 600 and some odd watt hours for the south facing panels, and about 400 watt hours for the west facing panels. And you can see it tells you exactly how much energy you've produced that day, and then you can actually look at how much energy you've produced each month. This is a great way because you can see if you have a real underperforming solar panel or something. Okay, what's wrong with that? Is something disconnected? And you can also just see if you're getting the kind of performance that you expected it to get when you design that system. I will say that when most people first get their solar installed, they're usually checking these monitoring systems pretty frequently, like multiple times a day. And then after a month of having solar installed, these things kind of rarely get checked unless there's a problem. But it is kind of fun to be able to see exactly how much energy your system is generating. So none of the systems that I've talked about up until this point include batteries. And the reason for that is because batteries are expensive. And although they are really coming down in price, up until recently, the options were somewhat limited just to lead acid batteries. When you have a grid tied system that does not have batteries, if there's a power outage, so if it's one of the windstorms in Fairbanks or in the Valley or anywhere else, and there's an outage, your system will not generate electricity, and you will, even though you have solar on your roof, your house will not have power. And that the reason for that is kind of like I mentioned, there's a rule that when these inverters don't sense a grid voltage, they automatically shut off, and it's a safety feature. But it's also a little disappointing because sometimes it means that even though you have solar on your roof and there's an outage, you have this way to generate electricity on your roof, but it's still not going to be keeping the lights on for you. So if you have a battery backup system, you can have backup power from your solar system. And basically there's a couple different, there's lots of different brands of it out there. I'm going to show a couple different examples here. Everybody always asks about the Tesla Powerwall because they have good marketing. I'm not sure there's anyone actually installing Tesla batteries in the state right now. Someone else might be able to answer that. But basically what you do is you have a couple of essential loads. Usually it's some lights and a refrigerator and maybe your boiler or something like that that's connected to that battery, and then all your other loads are connected to are allowed not to function during that power outage, and that way you don't drain your battery very quickly. It is important to keep in mind that most of our power outages in Alaska happen in the winter, and there's virtually no solar generation in the winter. So keep in mind that you will, just because you have a battery, it doesn't mean you have this endless supply of electricity, unless of course it happens in the summer, and then your array might be doing really well. But the quotes that I've seen for battery systems generally are about double what a regular grid tied solar system would cost. So keep that in mind. I realize this is a solar talk, but you know, if people are really concerned about backup power, it's pretty tough, especially considering the frequency that backup power might actually be needed. You also might just want to think about a transfer switch and a generator, and you can talk with most solar installers about what the cost difference would be between that and a battery backup system. This is another type of battery. I like this picture because I think it does a better job of showing exactly how you would separate some of your backup loads that you want to still have powered during an outage, and then how you would not feed your loads, such as a dryer and maybe television or an oven, that are going to be high usage loads. You're not going to be using those off your battery. And how you would have your solar system wired into that battery as well. And most of these battery systems have some kind of like a controller, and that's what this box right here on the top is representing. So that's batteries in a very, very quick nutshell. And we can talk about those a little bit more if folks do have more questions. And then the final type of system that is very popular in Alaska is just an off-grid solar system. These are kind of the original type of solar that everybody was installing up until probably about like 2010, when grid-tied solar started to get popular. These systems basically have your array, you have a charge controller. Charge controller basically controls the amount of power that's being fed into the battery so that you don't overcharge your battery. And then you would have some kind of an inverter to generate AC electricity, unless you had a really simple system that can just run off DC, which you do see from time to time. And that's kind of it. These are really simple systems. And there's a lot of cabins around the state that have these simple off-grid solar systems. So with that, let's take 5 minutes. So my voice can take a break and everybody can use the restroom. And I have 6:18 right now, so let's come back at 6:23. While we're taking a 5-minute break, there's a couple of questions that are going to be put on the screen. We're going to do a couple polls to learn a little bit more about why you're taking the class and what your thoughts are on solar energy. So 5 minutes. Thanks, everybody. Looks like it's been 5 minutes, so we'll get back going here. Let's start by going over this poll that we had. First question was, why are you interested in installing solar on your home? And I think the majority of people said it's a combination of lowering my electric bill and stabilizing energy costs, as well as concern for the environment. Although there were people that indicated that they were interested in charging their electric vehicle and that it was a good investment, better than the stock market right now, although that doesn't take much right now. And then the majority of you said that you don't have solar yet, but you are very interested in installing solar at a later time. So thanks for taking those. Thanks for taking that poll. That's interesting information. I'm going to go ahead and answer some of the questions that have the people have been putting in the chat. There's a question here. Are there any ongoing fees for the monitoring feature? There is not. Although again, I don't want to say there is. Never is a dangerous word. But most of the systems there is not. It's just a feature that's included. Some of the systems there might be an additional cost at the start for like a small piece of equipment or something like that. It's usually a pretty small. It's a small fee, a small cost compared to the larger cost of your system, but it is an additional cost or an additional piece of equipment. But again, each manufacturer, each inverter manufacturer have different ways of doing that. Is there an advantage to the line side connection to the system? The main advantage that you'll see, and the reason that you'll see that a lot of times, is if there's no, well, there's a couple actually. If there's no room in your breaker box, then they'll just do a line side tap or a line side connection. There's actually a lot of installers that pretty much always do the line side connection because it allows them to standardize how they do their systems, and it's easy. It also means that if your meter is located a long way away from your breaker box, it might, from a space point of view, it might be a little bit easier. But I would argue that one is not better than the other. Also, different utilities and different authorities having jurisdictions might have different requirements, especially from like a building inspector point of view. So that's something they should make sure and get familiar with. Someone asked about pole-mounted systems and some of these systems that have a winch on the back that allow the modules to be oriented at different tilt angles and different orientations depending upon the time of the year. Specifically, you can make those modules vertical. So you can basically make them vertical from, say, October through March. And that does a couple things. That's a more optimum tilt angle for the winter because our sun is so low on the horizon that the sun is going to be pointing directly at those modules. And then, of course, a vertical oriented array is not going to have snow accumulate on top of it. So those are great. There are some advantages to some of them. Again, it all just kind of comes down to cost. What the additional cost of that is versus just a regular old fixed tilt array, and taking a look at how much additional energy you could expect to get out of that over the lifetime of the system. But it also, I think it's important to think realistically about what you as a homeowner are going to do. A lot of people will get those type of systems and then never touch them. So it's important to think, am I actually going to go out there every fall and readjust the system? And more importantly, am I going to go readjust it in the springtime so that it maintains that optimum tilt angle? A question about having your roof replaced once you've decided to install solar. This is a really common question. if you need to get a roof replacement and you have a solar system on your home, that system has to be removed in order to replace that roof. Most reputable installers, if they see that your roof has less than 10 years of life left, they will usually advise you to get your roof replaced, and then they will install the system on the roof. Obviously, that's a personal choice. And so, you know, if you did have your system installed a long time ago and it's time for a roof replacement, you can call an installer, and most of them will are willing to go out, pull your panels, wait for the roof to get replaced, and then reinstall them. I don't have a cost for that off the top of my head, and I don't want to. I heard it. I heard some quotes, but that's been at least 5 years, so I don't want to give some faulty information. But it is an option. I imagine it's going to be at least a couple $1,000s to get that done. So yeah, someone asked, if you don't have a battery and the grid goes down, will you still not have solar from your panels? That is correct. And then the question is that always the case? So there is this new, there's a company that just came out with a system which they call which they claim will still generate power even if the grid goes down. However, there's a bunch of extra components that you have to purchase, including like this fancy microgrid controller and this other stuff. So I've never seen those installed in Alaska yet. It may become a thing down the road, but at this point, I'm pretty comfortable saying that if you don't have a battery, you're not going to have backup power from solar. And it's going to be, like I said, it's usually going to be more economical to just get a transfer switch on a small generator. As installing solar panels in windy areas. I used to live way up on the hillside in Anchorage, right on the boundary of Chugach State Park in an area called Bear Valley. We had an anemometer in my house, and it blew over 100 miles an hour every single year that I was up there. And that house had solar panels on the roof. The installer did a really good job of installing them, and put a bunch of extra racking and reinforcement. And I think in really windy areas, that's really what's needed, is to overbuild those systems. So they can be done, but it does take a lot of attention to detail, and to really make sure you're doing it right. And usually that means, making sure you have long lag bolts so that you're really getting a good connection to the roof. Plenty of racking. So normally you would have 2 pieces of racking per solar panel. I think in that particular roof, he had 3 pieces of racking per solar panel. Making it, also, if you are in a particularly windy area, it would probably be a good idea. And you have any neighbors that have installed solar, I would recommend you talk to your neighbors and see who they used. There are, I'm trying to think, there's probably about 4 active installers in the Anchorage area. And there's at least a couple down on the Kenai Peninsula, a couple in Fairbanks. But I will say that, I do think that there is room in the industry right now for additional solar installers. So if anybody wants to start a solar company, now's a good time. Question about the wind rating for pole mount. I don't have that information right off the top of my head, but those are widely used all over the state. And so I think you can design a pole mounted system for windy areas. You might have to use larger piling, 6-inch versus 5-inch. But again, I would need to double check that. I don't have that right off the top of my head. So keep those questions coming. I will try to keep an eye on the chat. I'm going to move on here so we don't totally run out of time. But those are great questions, and I think it's great to have that discussion. So now we're going to talk a little bit about solar resource data. particularly, what the optimum tilt angle and orientation of your system should be, and how you can do some research on your own to figure out how much you can expect your system to produce. This little bullseye graphic is for Fairbanks, and if you look on the left side, you can see the tilt angle of the system, and on the bottom there, on the x-axis, that's the azimuth angle. And the interesting thing, and then the numbers in the middle along like the topographic lines, those are the percentage of optimum output. And so the interesting thing is that big bullseye in the middle with a 95 around it, meaning you're going to get 95% of whatever the optimal output is at that location. It's actually pretty big. And so you can install a system at 60 degrees and even down to 30 degrees, and it's going to produce a very similar amount of annual energy. And you can install a system at southwest to southeast, and again, it's going to install a similar amount of energy. So the takeaway here is that you don't have to stress over getting a system exactly at 45 degrees and exactly at 180 degrees due south if your roof isn't oriented in those particular directions, and that you can probably just go with whatever design, or you can use a slightly less optimal system and really not lose much energy generation on an annual basis. So that's kind of the takeaway. See if my computer decides to go now. There we go. So people always say, well, wait a minute, we have sun like 24 hours a day in Fairbanks. How come I don't get the same amount of production as I do in Phoenix or Florida or wherever? So I always say, well, there's a couple different reasons for that. One of them is because we're cloudier than Phoenix. That's an easy one. But the other thing is we're further north. And so solar radiation is concentrated over a larger, rather than if you're on the equator, you have direct sun right overhead. So that's kind of an easy answer, and perhaps an oversimplified answer to a really common question we get. But the reality is we have 8 months of pretty good solar resource in Alaska, and 4 months where we don't have as good of a solar resource. And while you will have systems that will produce energy in December, I would, or in January, I personally have never gotten a sunburn in December or January in Alaska. And I always think about it that if I can be outside all day long and not get a sunburn, then there's probably not much of a solar resource during that time of the year. So taking a look at solar in Fairbanks and exactly how much you can expect your system to produce. So I said at the beginning that usually when we talk about solar installations, we talk in terms of the number of watts or kilowatts of installed capacity of a system. Generally, you can think about 3 panels is about 1 kilowatt of capacity. Keep in mind that if a system is shaded, pretty much just assume that it's not producing energy. Now, I know that's not exactly true. It is producing a little bit, but when you start thinking about how much energy you can expect a system to produce, if it's shaded, it's going to produce far, far less than it will if it's in direct sunlight. So in this particular graph, you can see exactly how much energy a 1 kilowatt solar array would produce during any given month. And this is assuming no shading and no snow coverage and a 45-degree tilt angle. And so the reality is because we all live in snowy places, you can probably get rid of that production in November, December, and January, maybe even February, depending upon whether you clear snow. By March, we're starting to get some warmer days. And so those panels are going to clear pretty quickly that first warm day we get in March. But This kind of gives you an idea about how much monthly energy and how much annual energy you can expect for a system to produce. So you can kind of use this and you can think, okay, well, my monthly electric bill is 500 kilowatt hours. Now I know what portion of my electric bill is going to be offset each month. And you can kind of go from there, and we'll talk about that here in a minute. So I am going to, give a quick introduction to PV Watts, which is a calculator that's produced by the National Renewable Energy Lab that everybody can use. And this is the URL right here, but I always just Google PV Watts and it comes right up. So if we just hit Fairbanks, Alaska here, it's going to send me to Fairbanks. It automatically chooses the Fairbanks International Airport weather station. I won't, if you really are curious how they get this weather data, you can send me an email, but it gets kind of complicated. Now I can say, okay, I'm interested in, let's say I want a 2 kilowatt system. So I say 2 kilowatts, we're going to use a standard module type. We're going to use a fixed, we're going to use a roof mounted array because I'm going to put this on my house. I'm going to leave system losses at the default. And I know my roof, let's say I have a 24-degree roof. I don't know. And you can not even worry about this, these advanced parameters, but just to kind of get a starting point here, and then you can just click next and it will tell you, okay, here's the monthly energy that you can expect your system to produce. And so again, that was a 2 kilowatt system, and I'm getting about 1,800 kilowatt hours per year. And so I show this because it's super user friendly and kind of you can just use it to really play with, you know, and figure out, well, how big of a system do I really want? So PV Watts is what that's called. Let's see here. As far as how to value solar in Fairbanks, and this could be really anywhere in Alaska, and you know, so when you look at a number of cities in the lower 48 and Hawaii, Fairbanks has the lowest solar resource. I don't think that's any surprise, but we have amongst the highest cost of energy of any of those cities. And so that means that when we actually look at our annual savings, Fairbanks kind of falls in the middle there as far as the amount that you can save with solar. And that's really one of the big reasons why solar is becoming more and more popular, even in Alaska. The other reason that solar is really taken off is because of something called net metering. Net metering was is a policy that basically allows people to get the retail rate for energy that they produce if it's self-consumed. Sorry, not if it's self-consumed, as long as it's below their monthly consumption. And it's been going on for about 12 years now. And so you can think about it this way. If you use 500 kilowatt hours and your system produces 600 kilowatt hours, if there was no net metering, anytime you produced more energy so that from your solar system so that it was just flowing to the grid, you would get the wholesale rate. So in Fairbanks, that's about 12 cents per kilowatt hour. But because we have net metering, you can get the full retail value of all this energy you produce on your system up to your consumption. So I said that was 500 kilowatt hours. So you're going to get the retail value for 500 kilowatt hours. And anything above that, so that there's 100 kilowatt hours left in our bucket, you're going to get the wholesale rate. So in Fairbanks, that's about 12 cents. In Anchorage area, it's about 4 cents. And it varies by utility, and it actually changes quarterly. It really improves the economics of solar in Alaska. As I said, it gets your in net metering, your consumption and your production gets netted monthly. There are the beginnings of some discussions to turn that into an annual net metering program, although those are very early and there could be some issues down the road. So at this point, those are just discussions. The maximum size for a net metered system is 25 kilowatts. And right now there are some limits on how many customers or utilities are required to allow into their net metering programs. No one is currently limiting, no one is cutting net metered customers off. And they keep most of the utilities keep raising their limits. Fairbanks raised their limit about 2 years ago. Homer has the biggest limit as far as the number of customers they will allow for their net metering program. Again, just kind of talking a little bit more about net metering. So if you're looking at your utility bill there in Fairbanks, these are the different charges that you will see. 25 cents per kilowatt hour is what your retail cost is. And that's what you're paying for the energy that you purchase from GVEA. And so I'm going back to my 600 kilowatt hour generation and 500 kilowatt hour consumption example, you're going to get 25 cents times 500 for the energy that you've produced. And then the additional 100 kilowatt hours that is above and beyond what you consume in your home, you're going to be getting this 12 cents for. And essentially, you can think about that. You can think of that as like the amount it costs the utilities to generate the power, because that's the cost of their fuel. As you're thinking about sizing your solar system, the quickest, from a simple payback perspective, the quickest payback is pretty much always going to be to match your consumption with your generation during the summer periods, because the summer periods is when you're going to maximize your solar output. And so that's what you can see in this little graphic. The blue is your consumption, and then the gray is a system that overproduces during the summer. The orange is a smaller system that just matches the consumption, and you can see the simple payback is less for the smaller system. But everybody has their own motivation for installing whatever system they choose. Some people want to go what they call net zero. So they want to produce as much power during the entire year as they consume in the entire year. Even though, because our net metering system is only a monthly net metering system, the economics, there's going to be an economic penalty for that. Maybe you're planning on getting an EV in a year or two, and you want to build a system that's a little bit bigger than you need right now. So it just kind of depends on everybody's personal situation. Again, just looking at the economics, this is just a quick, running a little bit here short on time, so I don't want to, I want to leave time for questions, but if you're interested in calculating your own simple payback, this is basically how to do it. You can get a lot more complex than this. You can take a look at the escalation rate of utility generated electricity. You can look at inflation. I will say, I just noticed there's a typo in this. So currently the tax credit is 30%. It changed about a month ago with the Inflation Reduction Act. So I need to update this slide again. I think I actually talked about, so tax credits, they were 30% basically. So if you spend $10,000 on your solar system, and that includes materials and labor, 1/3 of that, or not quite a third, but 30% of that is a tax credit. That went down to 26%. And then with the passage of the Inflation Reduction Act, it went back up to 30% for the next 10 years. If you are a small business, there's also some accelerated depreciation incentives that you can take advantage of. That's what that 5-year depreciation means. If you're interested in learning more about the current tax credits, you can go to this Department of Energy webpage here. And I threw that in the slides so that when they distribute the slides, you'll have access to that. Again, I will say we always get a lot of tax credit questions, and I will say I am not an accountant. I'm not giving tax advice. And so if you have a lot of questions about tax credits and that kind of thing, you should talk to your accountant. I'm going to demonstrate really quickly something we call our solar payback calculator. And this is essentially an online version of the solar payback equation that I just showed you. And of course, it wants to reload right now. There it goes. So you can choose your community. So I'm going to choose Fairbanks. Maybe just use Fairbanks right there. And basically what that's doing is it's choosing what solar resource data set to use. Let's choose the tilt angle. So again, this is basically doing a pretty simple PV watts calculation to figure out exactly how much energy you can expect your system to produce. It already has the solar tax credit built in. We can assume the default, which is a 20-year system life. You could maybe make that 25. Go into, you can put in whatever cost you think your system is going to be. This is cost per watt. I'm going to move this up a little bit. I will say that solar has gotten more expensive over the last year, like everything else. It'll be interesting to see kind of how the prices settle out in the next year or two. And then if your utility will net meters, so basically if you're on the rail belt, you can click that button here. You can add in what you pay for electricity. And then you can actually go in, and this is the avoided fuel cost. So if you're in Fairbanks, that was 12 cents. And this was 25 cents. And then you can actually go in and you can put whatever your monthly consumption is. And then this will show you for these this amount of monthly electricity consumption, a 2 kilowatt system is the quickest simple payback given the constraints that I put it at, with a payback of 9.5 years. And then it gives you a little graph right here about here's what your solar generation is versus your consumption. You can play with this. You can say, okay, if I want to put a bigger system in, what does this do to my simple payback, and look at all kinds of stuff. But again, this is a really simple calculator. It doesn't include inflation or utility escalation rates or anything like that. But it is just meant as a simple tool to play with, to just to take a look at what some of the constraints are with your system. The other resource that I want to pass on is something called the Alaska Solar Manual. This was a manual that was originally written by Rich Seifert in, I think, 1980s when the first one came out. He wrote 4 different editions, and then I partnered with Cooperative Extension in 2018 and wrote a 5th edition. And it actually needs to be updated again. Maybe someday I'll get time for that. But this is available at that resource, or at that URL listed at the bottom of the page there. A lot of really good information there, and everybody has access to it. It's free. So with that, here are a bunch of resources. Some of them that I talked about, some of them that I haven't talked about so far. There's some YouTube videos here, which are actually located on the ASAP webpage, where we go more into details about economics and that kind of stuff. There's a little bit of information on the Solarize program here. This is the Solarize Fairbanks Facebook group. If you want to get more into modeling, this is a system advisor model that the National Renewable Energy Lab puts out. There's lots of good information here. And then actually, this is the standby generator book is on the Golden Valley webpage, and there's a lot of really good demonstration, or a lot of good information there if you're thinking about backup power, and you're interested in either a generator or a battery or something like that. So I think with that, I'm going to stop talking. Let's see that. I think there are a couple of questions here. Oh, wow. Gary says the avoided cost for GVA is now 15 cents. That is crazy, and that I kind of wonder if they need to change their website, because I thought I looked that up. But yeah, so it's gone way up, especially with the cost of fuel oil. There's another question here. Does the thickness of the snow cover make a difference? So the answer is yes, but only to a point. You know, if it was a 1/4 inch versus 1/2 inch, then you might get a little bit of energy through that snow, a little bit of solar energy through that snow. But you know, usually we're talking about we're talking about several inches or feet of snow on top of our panels by the time winter starts to get to end. Let's see. Question about life cycle cost. So it says life cycle cost would be payback of an, yeah. So sorry, I'm just reading this here. Initial cost of system and savings would be saved, or replacement cost at the end of life. So yeah, if you're thinking about 20 years payback is 9 years, is really a net savings of 2 years. I have to think about that a little bit, Stephen. But and that's, you know, as I said, so I'm looking at Stephen's question as far as life cycle cost. Another really common way to think about this is ROI, or return on investment. And if you Google solar payback calculators or solar ROI calculators, there's a lot of examples of that online. But ROI is actually a more probably a more honest way of looking at solar payback and the value of a solar investment, because then you can compare the ROI of solar to the ROI of maybe something else, a competing investment or something like that. So yeah, 9 years of savings need to be saved. Yeah, I would agree with that. So any other questions? If there are none, I'll give you guys 4 minutes of your evenings back. I thank everybody for their attention and for showing up tonight. I hope you learned a few things. Feel free to reach out if you have other questions. And I know that they will be sending out a version of this presentation for you all to have. So you'll have all the links and all that kind of stuff that I included.
Hey, Chris, I'm going to add folks, you still have 4 minutes of your evening back, but if you can quickly bounce in and do the exit poll, that'd be great. I forgot to launch it before Chris wrapped up. So, and thank you for your attendance tonight and engagement and good questions.